It's just it's got like streamer quality. It's like you look like you could be streaming Fortnite with that background. I like it.
All right, I think soon we're gonna have some folks coming in.
Welcome to our few early people.
Yes, welcome. Let me share my screen and get started there. Welcome, welcome.
As is tradition, I always like to know where people are dialing in from. Hi here from San Francisco. Go
Here
ahead and
from Boston.
drop it in the chat.
Welcome, everyone. All right, see some more folks rolling in. Nice. We got all the coasts covered here. We'll get started in just a few minutes, so as folks continue to dial in. I'll give it roughly 1 minute. How are you doing today, Kelby? Are you
Doing
excited?
great. Doing great, yeah. I love talking about large spatial model. It's a passion of mine. It's not just like a fake passion. I don't just pretend to be passionate about it because like for like a marketing thing, like I actually think this stuff's really cool. So
That's all
I
good.
feel like you're the same too. It's like we
Yeah.
don't have to fake it with this, you know.
This is a one no one had to twist our arms to jump on this
That's right.
topic.
Not that I
Um,
ever fake it in other things in life, but especially not with this.
Good to clarify. Welcome, folks. I know most folks have just joined. We're going to get started in just about a minute, and feel free to start engaging in the chat. Let us know where you're dialing in from, and we'll get kicked right off. All right. Think we got a pretty good little contingency here, and as folks keep rolling in, we'll get started. But welcome to VergeSense's office hours. We do this, usually once a quarter. Either Kelby, our CTO, and myself, I run product here at VergeSense. Either us or some other members of our technical and product team will do these. And we were just saying we this is one of our favorite kind of webinars or kind of topic talking points personally because we get to talk about the cool stuff behind all of our products. Let's
One other thing I wanted to say, can I real quick, is like these office hours tend to be smaller groups. That's super conducive to us answering any question you have in chat. Just
Yep,
be interactive, ask stuff if there's something we say that's unclear, you want to go deeper on. That's the spirit of this style of webinar. So really feel free to chime in and ask us things, and we'll be sure to respond to everything.
really good point. Yep. So we got a nice kind of like cohort of folks. Please keep the chat live. We're gonna have lots of time kind of in presentation as well as at the end to take questions. And we'll invoke some polls. So let's get started. Today, we're going to be talking a bit about our large spatial model. If you've been following VergeSense, you know a bit about some of the AI investments we've been making and talking a lot about how do we predict in a precise and reliable and trustworthy way for workplace leaders and planners in a world where AI is ubiquitous and VergeSense is doing our part in that space. Today we'll talk about we'll go through the entire gambit. We'll start with a bit of context, remind you all what types of problems we're looking to solve, how the large spatial model works, what is it, what's the purpose of it. This office hour specifically is targeted towards kind of folks that would be using this as a planning tool, but also the ecosystem of other tools that are out there looking to kind of add the prediction capability of the large spatial model within their applications. You'll talk a little bit about that later as well. The second topic we'll talk about, we made a variety of upgrades. We continue to have new versions of this model, new capabilities across this model. Kelby's going to go through some of those new capabilities that are extremely exciting. You'll see those showcased for the first time today, and you'll continue to see them permeate through product and API over the course of the upcoming weeks and months. And then The third section, we'll talk a bit about the inputs that go into the large spatial model, as well as the capabilities of the outputs, the capabilities of the predictions. What can we do with them beyond just the planning capabilities we spend a lot of time on? We have a lot of kind of ecosystem players, partners, other applications that are doing interesting things with that prediction capability in the large spatial model. So we'll talk about that, inspire some additional thoughts for folks, and this is also a really good place for us to have discussion. And then lastly, we'll just give a kind of a little teaser into what's next. Let's get started. And again, just a reminder for a bunch of additional folks just joined. Just let's keep the chat active. We'd love to continue to chat with folks and let us know where you're from. So, to start, we want to talk a bit about, the concept of predictions and the domains of predictions. So ultimately, when we talk about the LSM, what we mean by the LSM is our large spatial model. It's an AI model we've trained at VergeSense. And the primary reason the model even exists is we wanted to solve the problem of being able to predict what will happen, right? In order to enable the what ifs, in order to enable future forecasting, in order to enable kind of modeling of what, various things, prediction is a key capability, and that's essentially what the large spatial model exists for. Now, it's helpful to break down the problem of prediction in our domain of workplace and real estate and built environments into two important problem domains. Number one is predicting demand. Basically, what that means is being able to forecast and understand how many people will actually be at the office. So if you think about this, you would think a lot about understanding your headcount, understanding your policy, understanding historical and expected attendance behaviors, eventually even understanding things like, more locale environmental metrics, things like, hey, there's a big strike for the transit system, or there's going to be a bad weather week. All of those things help answer the question of how many people will be at the office or in the physical space. Demand prediction. Number two is the behavior prediction. How will that number of people that we predicted to come into the office actually behave in the space? How will they permeate through the space that's been given to them? How will they deploy themselves across the various space types that exist? And that's how, really understanding how will they behave in the space and use the space. These are two extremely important prediction domains that help us understand the entire picture and enable that true what if, right? You can start to model things like what if I change headcount, start to understand demand prediction, start to understand how those people will behave. You can start to evaluate what if I change my space, and you start to understand the impact of that behavior change resulting from those space changes, et cetera. So, a very important context to set. And VergeSense and the large spatial model are able to support both, and we'll talk a bit about this in some of the new upgrades as well.
And one thing, yeah, one thing I wanted to add here, Kanav, is like I think these two concepts as a whole help describe like sometimes the concept of the large spatial model, predictive planning, the engine behind all of that, like what does it do, can be somewhat complicated. But I think if you take these two concepts and combine them together, literally what we're talking about is if you say, okay, I know exactly on a specific time in the future, maybe a month in the future, on a Wednesday in May. And Wednesday, we have a 3-day week policy, so a lot of people come in on Wednesdays. May is, high season or low season or whatever the regional variation is. We know how many people are going to walk in the door. And then our large spatial model takes that number and files them out into every space. Literally what we're saying with this prediction engine is at 2 p.m. on, May 17th, what is the predicted load in the office? Where will people be? How many conference rooms will be in use? What will be the desk load? And so truly we're saying predicting out into the future, pick a point in time. We are predicting, are you going to have a shortage? Are you going to run out of conference rooms? Will we have enough desks? Will team X or team Y be experiencing some pressure? Altogether, this is a model for just predicting out into the future how the office will actually be used.
Exactly. And that's a perfect transition into kind of how it works. Kelby, you want to walk us a bit through the large spatial model?
Yeah, we call it the large spatial model. That is no accident. A lot of the discourse these days is around AI and large language models. Part of calling it a large spatial model was we want to tie ourselves to the hype in some way, but the truth is also this is a real thing. This is a foundational model in a very similar spirit of a large language model. One of the things we always like to really emphasize is early on, we were one of the companies, every company took their database and put a large language model on top, right? You connect ChatGPT to the database and it lets you ask questions and run code and write queries. That's not what this is. This is something different, which is a deterministic sort of algorithm, an algorithmic model, kind of like the actual AI model that's running on GPUs that's powering something like Claude or ChatGPT. It's an AI model we trained from our unique data set, where the analogy with large language models is the internet and human communication and books and just how people communicate with words. Well, we have sort of an analogous data set of how do people use space. We have all over the world, 250 million plus square feet of space, sensors covering to an individual room and desk and space level. What are the patterns that people use space with? What influences how people use space? How does time of day influence how people use space? What are the different space types? And sort of those become the language. The spaces become the language of the model. And then our model is predicting how people will interact with those spaces. We're one of the only, I would say, we're basically the only people in the world that have a data set like this that can take sort of a breadth of data like ours, anonymize it, and turn it into a model like this that can be packaged into basically a benchmark that's usable in a flexible way. Yeah, and then this becomes the engine for everything. Yeah, sorry, go ahead, Ken.
No, no, I think the one thing I was going to add, because I think there's going to be a couple of the updates that you've done to the training data, et cetera. I think the story I like telling folks is if you've been following VergeSense for from 2022, we did launch to your point the Workplace Assistant. It's a product we still support, and it is essentially an OpenAI model wrapped with our own kind of unique context tuning to let people ask questions of their historical data, right? And it does a really good job of that. What inspired this model development from then to now was, as we dug in and chatted with folks and on what are they actually asking this workplace assistant, two real things. One, just like looking into his history, and it was did really good job of that. They're trying to understand, hey, last Friday, right? Did I run out of conference rooms? People were, asking us about that. Tell me how often we're, how well our desks used, etc. Pretty awesome at that. The other most common thing people are asking are all the what if scenarios. They're like, hey, I'm working on a headcount increase plan. What if, given all my historical data, we increase headcount by 10%? And what we found was the model would intelligently and confidently answer with something. But those responses were essentially just a logical answer, not necessarily a true prediction of how the space will behave. And that's where we essentially birthed the large spatial models to say, those what if questions require a completely new foundational model capability. And that's where the large spatial model exists.
And yeah, and worth noting too, like this is a philosophy I think we've learned and a lot of folks have learned as they've interacted with the sort of standard ChatGPT, Claude type tools is they are very good at their job and they're very good at responding intelligently and they get better every day. But if you as a workplace leader or the other folks on the call say, I'm in a meeting with, my CFO. Here's the decision I'm making. And they ask you, how do you back up the decision you made? And it's like, oh, well, I asked Claude and Claude just spit all this out. You'll get laughed at, right? Like that, it's okay to use it in the context of your job, but there has to be some framework that you understand that's some type of middle layer in between the actual sort of strategic thinking, which is what Claude and ChatGPT are so good at, and the actual like math and determinism and spreadsheet style logic that actually calculates and predicts how the spaces are going to be used. So our philosophy with this is a layer that gets you the best of both worlds. You can still use that sort of agentic front end that helps you be strategic and use the outputs to make sort of creative solutions to some hard problems. But when someone challenges the assumptions, there's a very well-defined deterministic modeling framework that is the thing that produced all of the numbers and risk levels and dates when we think we're going to run out of conference rooms, et cetera. So you kind of get the best of both worlds. That's the philosophy.
Exactly. And that's a perfect tee up because later we're going to talk a bit about, if you're building agentic solutions within your platform, you're trying to do some, use AI to make decisions as an actual kind of workplace leader. This is the type of model and the tools that surround it to help you do that deterministic work. I think let's jump right into kind of what's new. I think there's some exciting things that we have just introduced in the last couple of months. So, Kelby, over to you.
Yeah. This is a thing that you'll continue to see is we're continuously updating this thing, improving this thing, the thing we call the large spatial model. And one of the most basic things is similarly to the analogy with large language models, which are, you know, trained on words, on the way people communicate. Our data set is at its core. sensor data, right? It's anonymized sensor data, counts basically in rooms, correlated to time. Um, and as a company, we have a very wide coverage of regions, industries, just general cohorts, and that's always expanding. So, like at a very basic level, we are just always getting a better anonymous cross section of how people use office space. Right now, just as a fun um, data point of exactly the scales we're talking about, we recently ran a regeneration. We're constantly regenerating the data set just to make sure it's up to date. 100 million data points, right? And these data points are heavily curated only at times where there's meaningful usage in spaces, in places that we know have a high quality of data. And even when we really narrow it down to like times when people are using offices, times where we actually have a high quality data set, we're still talking about, over 100 million data points. So it's really the scale of the data. And then we also are combining other contextual things with that data. So what regions were these data points collected in? What are the cohorts that these data points correspond to? Is it the simple things like the room types? Obviously, we talk about this a lot. We classify anything that's collaborative, and everyone calls a conference room a different thing. We call it a, enclosed collab space, things like that. So that terminology is very important to get right in the data set, but then also all this other cohort stuff like region, industry, team types, et cetera. But not specific to a given customer or nomenclature, generalized into a way that you can actually compare and anonymize and combine across companies and make sort of this global benchmark.
Exactly. And I think in this kind of the first kind of announcement of update, the this new version of the model, I think you described it as two kind of key updates. One is architecturally, we've included the ability to have that additional context of regions, et
That's right.
cetera, team. And then on the training data side, you had mentioned that we're able to not only that 100 million data points are, that's not a static training set, that's a continual, almost like annually updated data set. And I think we've expanded our training window from 3 months to 12 months as an ongoing
Yep.
rolling.
Yep.
Um,
Interestingly enough, yeah, some of the older logic was like find a 3 month period that is free of seasonality changes. It's just hard to do. It's a lot easier if you just take a rolling 1 year window, then you capture the entire year. You take seasonality out of it. If it's always June to June, May to May, you know, April to April, et cetera.
yeah.
So yeah, that was a big update as well.
Yeah. So already starting to see kind of key and important precision updates as a part of this. Also, just what we're going to talk about next, which is the ability to actually now start to allow us to use the large spatial model in different ways, with a feature we call workplace factors in our product, but also a capability within the large spatial model itself. If you want to
Yeah,
talk about.
we'll talk. We're going to talk a fair amount about this today, because we're super excited about it, and it's all about cohorts and making sure that our model. One of the things that we claim and we stand behind is that really the minimum thing you need to get value out of this system, the large spatial model, is a design, is a floor plan, is some expression of the actual built space. If you give us that, our model will surprisingly accurately, even with that minimum level of context, predict how the space is used, predict what will break first, predict, are you, constrained by desks? Are you constrained by conference rooms? What's the load level at which you'll start to experience problems? Um, that's all you need is the design. However, the obvious question we get from customers constantly, and have continued to get from customers, is like, okay, like I get that this is accurate, but really I know that there's unique characteristics of my type of company, of my people, that yeah, you may be close, but I know there's something extra encoded in the fact that I'm a finance company or I'm a tech company or I'm a biotech company. And so we said, yeah, that's right. We have a very wide, one of the things that I feel like has always been an advantage of our company is that we're not just a measurement solution for like tech companies in San Francisco. We are a measurement solution for everything. We have every industry. We have oil and gas. We have finance. We have tech. We have and everything and food and services and everything in between. Um, and so we actually do have a really high quality data set to understand if you tell me what region you're in, what region of the world, what country, if you tell me what industry you're in, and if you tell me things like what teams or what's the facility type and what teams are assigned, we have enough data to sort of figure out how those specific cohorts will influence the behavior of your space. And that's something we call workplace factors. And so you're able to say, even if you don't have sensor data, you can give us some of that unique quality that sensor data would have given us by telling us the cohorts that you're in, industry, region, et cetera. And that will influence simulation and more accurately predict how your specific design will be used by your specific type of people and your specific type of company.
Exactly. And, we'll talk a bit more about some ex real examples that you found in the data of this so people can kind of understand. But I like to kind of step in here and talk a bit about, how to think about this. I always speak about kind of the dimension that all of our customers are making decisions across. At the end of the day, they're thinking about like, how precise am I making this decision? And, with VergeSense and our history is providing, we would consider the best in class kind of measurement solutions for how to measure actually what's happening in your space. There've really been two spectrums that existed. One was you're either making decisions on your space just based on the advice of the consultants you're relying on, or the experience that your staff has on how spaces are used, maybe some interviews and behavioral heuristics you're gathering on one side. The other side is you have the most precise down to a complete time series measurement of every single space. Those are your spectrum. Like you're either understanding exactly how it's used or making intelligent assumptions of how it's used. What we're enabling with this product and the large spatial model is there is an ultimate spectrum of precision that exists between that, right? Because there's an ROI of living on both sides of those fences. Can you afford to put sensors in every single space? That is ultimately exactly how your people use space. Inversely, can you rely on assumptions alone to make some key decisions? So how we think about this is within the model, there's step functions of precision increase as you add various levels of context. So space data only, to Kelby's point, if you just give a floor plan, it's going to use VergeSense's benchmarks and start you off with more than just assumptions, right? Hey, here's how a general pool of employees in a similar kind of for your specific space would behave, in that office. The next step function is this descriptive metadata. The workplace factors, as we call them, tell us a bit about the spaces, tell us a bit about the people, tell us a bit about the regions, to hone in that actual predictions and say, actually, we're modeling how your office should be used, not by a general pool of employees, but actually based on an employees in their specific characteristics that you describe. And then at the end of the day, another step function increases your people. How are your people behaving in this type of space, which is the measured data if it exists? So a good way to think about precision is it is a continuum, and the large spatial model kind of acts across that entire continuum.
And yeah, and one other thing I wanted to add there is a big philosophy that we have in this whole system is flexibility. We think that there is a minimum level, right? There's a minimum level of context that we need to be provided, but this is even just like a relatively narrow view into the flexibility of the model. Our philosophy is whatever you got, like we will take it. If you have some extra piece of context kicking around, in a folder somewhere and you can give it to us, that makes the simulation better. So if you have third-party sensor data that maybe is only partial coverage, or you have partial coverage of our sensor data, or you have badge data, or you have booking data, or you have some other qualitative observation that you can give us, anything that you have will make the simulation better. And so we're working really hard and continue to work hard on making the system flexible to just collect. If you whatever you have, provide that to this simulation framework, and it will tune in and make the predictions more accurate.
Exactly. All right, let's talk a bit about how these workplace factors work and maybe some of the real stories you found. Maybe you want to start with some of the heuristics you generally found, and then I think we're going to talk about two examples.
Yeah, I mean, I think what's nice about the UI here is it's very self-explanatory what it's doing. As you use this concept of workplace factors. And actually, one thing I'll take a big step back. This is sort of like a configuration modal in our predictive planning tool, which lets you pick these different cohorts and see how it affects how VergeSense's model predicts it will shift the usage of space. I genuinely think this could be like a product on its own. It's sort of like a programmatic benchmark, right? If you see a lot of the consultative companies releasing versions of this in like PDF form, this is truly an interactive version of that. You can pick whatever combination of cohorts you want to simulate and see in real time exactly how it will shift people's behaviors from our four categories of space: open collab, enclosed collab, open focus, and closed focus. You'll see there's sort of some like logical things that happen as you click finance or tech or Asia or North America. You see it in real time. Then obviously when you lock it in, filters down to all the other tooling in the actual predictive planning tool we've built and changes the way things are predicted.
Exactly. The one thing I was going to plug, also, pardon my not knowing how to loop the video here, but I am clicking play as it continues to stop. But one of the things that I think I'm going to plug for the benchmarks that the static benchmarks that Kelby talked about, we have those as well, right? So we publish a index, a plug, check it out. It's going to just launched one recently this quarter. There'll be another one next quarter. An index that talks about a global set of metrics of how the broader industry is performing. We break it down by these, organization types, regions, etc. But the main difference here, and I think this is kind of the active productization that Kelly even talks about, which I totally agree with, is this is applying that benchmark. One, it's simplifying it down to these categories and normalized space types. And two, it's actually applying it to your design,
That's
right?
right.
There's a difference in understanding general patterns. That's a description of the data set. And applying it to your actual space is that prediction transformation that exists. So I'm going to go to the next slide and we can talk about some of these examples that you found.
Yeah, I picked out a couple of just like really, really simple examples because like the philosophy with this thing, it's funny. You talked about there is a lot more than meets the eye with this. It's not just like, oh, if you click on tech, 2% more enclosed collab. We shift people from enclosed or open focus to enclosed collab, and like that's it. That's the extent of the algorithm. That's not it. It really is just extra context provided to the simulation engine, which will behave somewhat differently depending on the design. If your design is really enclosed collab heavy, a finance team might interact differently with a space that has, tons or way too many conference rooms than a tech industry company would, or vice versa. And all these, and the way they combine really does change things. But this was a really fun tool to build because we have some preconceived notions. We work with a lot of different industries, a lot of different companies, and sort of the thing I always like to say is like we have the answer sheet. Like we have sensors across cohorts. We know what the truth is. We know that, and when we're building these algorithms, we're not just like, oh, it feels right, and therefore ship it. We look, okay, it's got 3% error in this industry and 2% error in this industry, and so that's good enough to ship it. It's very well sort of characterized exactly what the accuracy of the system is when applied to these different cohorts. But also, it's important that it feels right too. Like we're not going to ship something if you click it and like you're like, what, that doesn't sound right at all. Um, and so, a good example of this that I just thought was like really straightforward, um, and a thing that we actually see from some of our customers is just this comparison of like a technology company to a finance company. It's sort of often on different ends of a spectrum of just like the type of workforce. They have different needs. They tend to be working on different types of projects. And in this specific case, one of the things that the tool is outputting and one of the things that is intuitively we see is that tech companies, technology companies tend to use more conference rooms. There's less sort of just sitting at a desk doing standard work and more being in rooms, being in collaborative spaces, etc. And then yeah, I don't know, Kanav, if you want to add
Yeah.
something or we can
I
go
was just I was
finance.
just gonna say this part was counterintuitive to me. As you know, I used to be a software engineer too. I was like,
Yeah,
I assumed that it would actually be higher open focus. And then you kind of like step back and you think about like this is when they're in the office, right? In a world of hybrid, you're actually, trying to predict when in office, what is the distribution of behavior. So I thought this was an interesting example.
totally.
The
And
next,
then yeah, and then the yin to the yang here, the finance, much more desk heavy. Open focus is our normalized way of referring to desks. The standard finance company has a lot more people sitting at desks, presumably maybe on the phone more or heads down in work and less of that like open collaborative usage or
right.
in closed collaborative usage. And so there's like we can tell you this is true. Whether this sounds right or sounds wrong, I think from my experience and how I've interacted with these companies, this feels right to me, but it doesn't matter whether it feels right because we have the answer key. We know exactly this is how these types of companies use space. And it probably wraps in a lot of different factors, Kanav, like you mentioned. It's like it also encompasses the dynamics of maybe tech people only come into the office when they have something to collaborate on, and maybe finance companies are required to be in the office full time, and so there's a lot of just more of like the standard work being done. And so yeah, yeah,
Exactly.
you see some really cool patterns arise from this, and I love just sitting here and clicking the different buttons and seeing how the different bars move because you learn a lot about human beings and how they interact with space just by using this tool. Obviously, it gets even more powerful when you hit apply and see it actually gamed out into the actual simulation and risk thresholds and all of that.
Exactly. And I think just summing up this upgrade in this session, it is one of our biggest ones, is you're essentially now not only getting the power of a benchmark, you're now seeing an applied benchmark in a specific design, right? So you're saying, how would people of this, cohort use this specific space? That's the power of benchmarking that actually starts to become applied benchmarking.
I see Nick with a question in the chat. I love this question because like this is a potential explanation for some of the differences we see in these cohorts and how people use spaces. This is not something we have in our data set. When we look in our data, down to an anonymized desk level, we're seeing just sort of on or off, is it used or not? And then we also have this indication of like passive usage. Did someone leave their stuff at the desk and leave it unattended, but claim the desk with stuff? We don't have the user was on a call. However, one of the things that this benchmark might actually be encoding is kind of to Nick's point, that maybe in finance people take calls from their desk, and maybe in tech people there's a culture of taking calls from the room. Whether we capture that essence of the cultural thing that's happening or not, it still expresses itself in a different usage of space. And that different usage of space is what then defines sort of the friction that will happen. In finance, you're going to have a lot less of the one engineer sitting in the conference room taking a call, and then I actually need to have a meeting and there's no conference rooms available, right? That effect is attenuated in finance, maybe because of the culture and maybe because people are taking calls at desk, et cetera. So it's really interesting that, yeah, there maybe is some more complex cultural thing happening behind the scenes, but the expression is where they actually use the space. They vote with their feet and go to the actual spaces that they need for their specific type of work.
Yeah, good question. Really good question. All right, let's go to the next kind of key and kind of huge upgrade that we've done, which we call, pooling or kind of capacity grouping. Kelly, go ahead.
Yeah, yeah. The quick overview of this is the original launch of this whole tool set assumed at some level that floors were sort of the building block of space, which they are. I think that's like a really sane assumption to make about how spaces are used, how buildings are used. Um, but we started to see some interesting cases of like, the intention of how these things are simulated, the actual tool, the large spatial model, our predictive planning tool is supposed to express when you're going to start having risk of things breaking and things, not your space not working well. You're going to start to have pressure, employee experience is going to suffer. You're going to have people looking for a type of space but unable to find it. And in any building and any culture of any company, there's expectations about what you should be required to do. So the most obvious example is like, if I need to find a conference room, what is the expectation of like where I should be searching for it? Some companies, they have a very strict neighborhooding policy, right? You have a neighborhood, there's an area of the floor that your team is assigned. There's conference rooms around there. The expectation is that you're able to find a conference room in that neighborhood. Some companies, it's just sort of the whole building is fair game, roam around wherever you want, go find a room wherever. And so, depending on what and there's everything, there's a bunch of different, versions of that in between, a lot more subtlety there. Um, it's important to capture that in this tool because depending on how you region off your simulation pools, and we call these pools, what is the unit of simulation where the sort of expectation is that employees shouldn't have to venture outside of this region to satisfy their need for work? Um, and so we have now a flexible framework for saying you can pool up your space however you want. You can do it at a neighborhood level, you can do it at a floor level, you can do it at a building level, you can do, mixes and more nuanced versions of this that really capture the sort of expectations of how your office is meant to be used. And so we can say, hey, like we have some customers where like there's a whole floor of conference rooms and a whole floor of desks. And like we actually have an expectation that if people want to have meetings, they go up to the top floor. And if they want to do focus work, they go down to the bottom floor. That's not like a problem in design. That is the expectation. So you can put those two floors into a big pool and simulate them as one big pool and now say, okay, it's actually a problem if they can't find any conference rooms on the floor above and they need to go somewhere else in the building, et cetera. And so it's a flexible way to encode that culture of how is your design actually meant to be used.
That two floor example is a really good one. I was just about to tell a couple of like example stories for what we've been hearing from our users and customers. So, before this capability, when you model the breakpoints, for example, we tell you you have a four-floor office. We're saying, hey, your conference room or your office breaks at, 300 people when it's designed for 500. And we tell you that because the fourth floor no longer has conference rooms. Some people are saying, yeah, that is how I expect people to use space. Some other people are giving us feedback that like actually if they can find a conference room on another floor, I don't expect that to be a breaking point. Now you essentially in that example you would pull all the floors together and say, hey, this is a commonly used space and only call it a breaking point when there aren't actually conference rooms available across the entire inventory of space. So that's a really a powerful capability of this model. Again, also available over APIs in the modeling capability itself. The other thing I think is like a little transition into the that it starts to enable us to do is, and this is kind of a teaser into what's coming within our actual predictive planning product, which uses the large spatial model, but the large spatial model already supports, is our ability to go granular as well. Instead of pooling multiple floors into a larger group of space granularity, allowing people to actually simulate that neighborhood level representation. Can you have the sales department defined as one capacity of space, understand if they are actually going to ever hit a shortage of space. Anything you want to add to this, Kelby?
No, no, I think this is just sort of the expression of a lot of the things I was just talking about.
Exactly. And I think some of the things that will you'll hear from coming in this next quarter that we're actively working on is actually allowing that assignment of teams and that definition of teams so you can start to model that supply and demand at the team and neighborhood level as well. And the modeling capability here has been super powerful to enable that.
We just got an
Yeah.
avalanche of questions come in. I don't know, Kanav, do we want to hit these all now, or do you want to go through your question and then we hit them all at the end?
Maybe let's do another. I think we got one more, and then when we pause before the next one, let's like take a pause and do these questions. I think it's great
Cool.
to keep it going.
Love it. Yeah.
Um, all right, I think this is the last of our awesome updates. You want to talk a bit about this? This is the other dimension of prediction that we've been focusing on, which is how many people are actually going to come into the office.
Yeah, I'm super excited to hear people and see people react to this feature because I think it sounds somewhat simple on the surface, but I do think we have like a very unique ability to do this in a way that's better than it's been done in the past. And the idea is that okay, yeah, a lot of what I was talking about with like the workplace factors and the simulation of space and how do people use conference rooms, that was on the supply side, if you remember that the original slide that Kanav hit. On the demand side, it is obviously also important to have an accurate prediction of how many people are going to come into the office on a given day of the week, on a given month, at a given time. Uh, and the thing that we know every customer has some access to, the minimum level, the minimum bar for basically everyone is badge data. And so one of the things we can do, interestingly enough, with our whole sensor suite, we have Wi-Fi product where we have sort of whole floor, whole building Wi-Fi coverage. We have sensor data. We have multiple sensor feeds. We have entryway sensors. We have all these sort of sensor feeds. We can actually do a really good job of figuring out, what is the badge data uh, um, signal that would correspond to this actual number of people entering the office. Anyone on the call who's ever dealt with badge data knows that it's hard to sort of figure out what the ratio is. There's badge in but not badge out. How do we figure out what the peak people actually in the building was? What is the characteristic of my specific workforce? Like, do they leave early? Do they leave late? How do I turn these numbers into actual like peak simultaneous usage of an office? We're launching that because we have a data set that lets us very accurately predict that. And so what you can do now is just whatever badge data you have. This doesn't need to be like a deep, linked integration with some badge data system where you have to set up an FTP or an API call or API keys, whatever. Just a decent amount of badge data for a given building lets us characterize your sort of demand profile and then very accurately predict out into the future. And so, the way you literally use this tool, give us a badge data upload, anonymized in whatever format you have, whatever is the format you use to do your job. It can be a one-time thing, upload it to the system. We'll create sort of a demand profile that then allows our algorithm to very accurately predict out into the future Even for the past, what was the peak number of people that were actually simultaneously in your building, even though your peak badge-ins was 500 people, that peak simultaneity was like 300 people or something like that. Can do that for the past, and then for the future, it creates a profile for us to project out and predict exactly how many people will be simultaneously in the building, and therefore what the load will be on the building as a synthesis of what the actual badge-ins for the building were. So we're super excited about that feature.
Yeah. And I think the one thing I wanted to add, I'm just gonna, sorry, make this really go back to this
Yeah.
screen here. The two things this actually does enable is yes, it makes a demand line go into the future. So you now have a, representative expected demand based on both history and our benchmarks. It's an important call out. We do use our seasonality across our global benchmarks as a part of that tuning of the forecasted how many people will come into the office as well. The second thing it enables is those what ifs. Now that we understand not only, sorry again for uh, moving around, but not only do we understand your headcount, your policy, we now understand the adherence essentially for what happens because of the historical badge data. When you now do what ifs, for example, of a headcount increase, we can understand that loss function down to the adherence. If you change a policy, we can understand the impact of that adherence and the change. And you can even have, customers have been modeling changes in adherence, right? If you now have a policy that says performance reviews include attendance validation, you probably expect a higher attendance and you can start to model adherence changes as well. So the what if, it's
Yeah.
super critical for that what if.
It's a great call. And like a very concrete version of that to take it just one step further is like, okay, here's the badge data and here's sort of how people show up throughout the week. And if you give us the sort of context, hey, actually what I have asked these employees, and you can subset this out by teams as well. I've asked these employees, the policy is 3 days a week, right? Not everyone's coming in 3 days a week. There's a very nuanced expression of how employees react to a policy that their team has on how many days a week they should come in. The badge data really expresses not just like what they're really doing, but what they're really doing when asked to do a specific policy. So then our system can then predict, okay, you've asked them to come in 3 days a week. What if the requirement was down to 2 days a week or up to 4 days a week? What would happen? Knowing what we know about their adherence to the existing policy then lets us game out and simulate out what would happen if you changed the policy or went to totally flex and really game out those scenarios and those changes in policy.
Totally. So this is one of the ones that I'm super excited about. This is also a teaser of something that's going to be available within the predictive planning product that VergeSense offers in the upcoming weeks and month, but already kind of modeled into our large spatial model. All right, so there's a couple awesome questions. I took a crack at a few of those. I think the others we can take live, and then again keep them coming. We love these. I think. I'll take Kara's questions here. Six of them very well articulated. I think I can kind of go down the list, and some of these actually play really well into some of the section we have next into what is the input outputs of this actual model. So the first question, I think a lot of people have this question, which is how do you position yourself, including the large spatial models, relative to the enterprise space management platforms, like JCI OpenBlue, the other IWS platforms? It's a really good question. I would answer this in two forms. Number one, from the large spatial model perspective, we built this model and have explicitly from day one distributed as a foundational model via API as well. Our main focus is prediction capability is missing. Just like back in the VergeSense's infancy, we said measurement capability was missing. We want the ecosystem of tools and decision makers to have access to measurement. Now we're essentially with a large spatial model saying we want the ecosystem of tools and the decision makers to have access to prediction. Large spatial model is actually accessible to those platforms. And nothing announced yet, but we are talking to these as well as JCI as well as other space management solutions to actually start to incorporate the large spatial model in their own predictive capabilities. At the end of the day, this goes into the second question. These space management platforms is a lot of where one, the source of truth of the space information and the people information lives, and two, it's also the source of truth of once the decision is made, where does that stored, right? And we are trying to play perfectly within that. So as we think about what the VergeSense platform and our model is outputting, it's taking that source of truth from these systems, the space information that's required, the team-based assignment information that's required, that's ultimately coming from your IWMS or space management system, And the action decision that's landed ends up likely living in your IWMS as well, or your space management tool as well, whether it's the actual stack plans that you landed on, the actual expected change in supply based on your lease decision that's coming up, the expected test fit changes that are coming up. So the interaction basically is to take those social truths and allow for that decision to land back into that system. The large spatial model, again, API first model deliberately. We do have a predictive planning product that we have built around this large spatial model. The reason we've built around this large spatial model is, again, customers are coming to us for that decision-making layer, extracting the insights, doing the what if situation scenarios, getting the recommendations, kind of exactly how you posed question number two there. And we're trying to have that step essentially be the step of the process that's hyper simplified. Meaning, think about how much time you, your team, and your consultants are spending in that what if scenario planning mode. We expect that to be turned into days instead of months or minutes even. And that can happen within the VergeSense product, or if the large spatial model is integrated in whatever other system they're using in those products. And ultimately, that decision is meant to suggest and again, a teaser for a longer term path of like even integrate directly into the decision into a place where you actually capture your source of truth.
Yeah. And one thing I wanted to call out there too, Kanav, is like as we've built this engine, I like to call it an engine, right? It's an engine for other decisions. It's an API and engine that can feed any system. That's something that we're very like committed to is allowing this to be API, to be the engine behind other workflows. That being said, this engine did not exist before.
Yeah.
And the sort of the capabilities of it sort of unlock new ways of doing some of these jobs, the stacking and planning, the design jobs that like weren't possible before. So there is some element of like with access to tools this powerful, the actual workflows built on top, there's better ways to do them now. And like we want to influence those. We want to have our engine be the thing that powers the way those workflows are done better in other platforms. But we also have a strong opinion on what those workflows should look like, which we're building into our own platform as well. So I think there's a little bit of like a, this capability not existing before, now existing makes the way that some of these jobs are going to be done a lot different.
Different.
And we just want to make those jobs better, those workflows better, and we're going to do that however we can.
Yeah, well said. And I think the next couple of questions actually tie pretty well as well, which is, fully deployed environment, which system do we serve as a source of truth? I think, we stand by that. The source of truth exists today. You have a space inventory that does exist today. That's where we should be pulling that information from. We have a variety of integrations. You can easily import that information. And that's, we kind of stand by the source of truth. I think the way that workflow and the decision is made is kind of what we're trying to essentially innovate on and revolutionize. Um, and then what decisions are expected to be made in versus dashboard or the predictive planning product versus external systems. I think again, back to Kelby's point, as this model gets integrated into the other systems, we are fine. We would love for every system to have the ability to be predictive. Our predictive planning product is essentially we expect the decisions we expect to be made there are whatever is likely today happening in decks and spreadsheets because the concept of modeling and every company is doing this. The what if scenarios are happening. These are intelligent workplace teams that are doing these what if scenarios. What if we go to 3 days a week to 5 days a week? What if we go and reduce our space by one floor because the lease exit option is coming up? Those what ifs should be modeled, quantified, transparent, and understood within our product, within the predictive planning product, or if large spatial models powering a different product in the future. And then data requirements. So perfect segue. So back to, we kind of touched on this a little bit back, but I'll make it super concrete. At the end of the day, the large spatial model reduces the barrier to intelligence completely, meaning all you need is that space inventory source of truth. You need a floor plan. Even simpler, you could just go on with the space metadata inventory of like how many spaces of each capacity and type. You just need to understand your space inventory so that you can start to analyze the expected behavior of people. Now, the people you're modeling go back to that workplace factors concept, right? Is it a general pool of employees? Is it a tech pool of employees? Is it a tech pool of employees in London? And none of that requires any other input other than the space inventory. Now you understand the step by step. I have a floor plan or a space inventory. I understand where the bottlenecks in the space are going to be, where there's a mismatch in my space design. What do I actually think we can comfortably support? We think we can support 500 people here. The modeling shows that probably around 350 people, we will hear those complaints. Not because there's not enough space, but because conference rooms will run out. That entire journey I just described is possible with simply a floor plan. Um, Now, the other things we've touched on as well is now you increase the context, you increase the precision. So to predict more accurately how many people are coming into the space, you give us badge data, we have a better understanding of adherence, and be able to model that forwards. If you give us insight into any sort of measured data you have, VergeSense sensors, third-party sensors, I think Kelby says even a spreadsheet of 1 hour of how many people showed up, but I'll put an asterisk next to that one. But any measured data about how space is used it will increase the precision of how people distribute among space. You mentioned booking data. That's another teaser. So that's something we're looking into as well. Booking data provides a really interesting kind of balance of not actually occupancy, but intent of occupancy and more forward looking. So we're going to be pulling that in. It is not today in the model yet. But really, really awesome questions. Um, and I'll continue to go forward. And then I'll do another. We got 10 minutes left, so I'm going to kind of go through a couple of these slides, and then we can do a final batch of questions as well. So, the thing we want to kind of end on here is there's really are a variety of use cases that we've been collaborating already with the ecosystem on. A variety of providers of space management solutions, employee experience solutions, design solutions, building management solutions. And at the end of the day, when you step back and you think about the ability to predict how many people will be in a built environment or how will people use a built environment, you start to unlock pretty impressive use cases across a variety of use cases. The first is portfolio right sizing and scenario planning, the what ifs we talk about. Now, this is one we've been focusing heavily on because we built a predictive planning product around the large spatial models predictive capabilities in this exact domain. The idea is modeling consolidation, expansion, hybrid policy changes, predicted outcomes of each one of those changes. So this is kind of a sweet spot of what we know and what inspired our actual creation of the large spatial model and what we've been focusing on. The second is around design validation. We've been starting to actually do a lot more of this now, and even collaborating with some of the new players in the industry that are trying to automate the test fit process. But if you think about the entire new way of validating it, there's really three things in the design workflow. One is a global space program, a standards by which companies design space. We have customers that are auditing that design standard program against the large spatial model, saying, hey, we thought based on our employee pool, these for a 1,000-person office, this is what we would need. Let's go and audit that. Let's go in and understand if our standards need to be changed. Number two is auditing an actual specific deployed standard. So I have a specific office, we designed this site, score that design for me. How inefficient are we? Where are the bottlenecks? Where are we misbalanced? And that's kind of the second use case of this. And the third is actually create a new test fit. This is where think about the ecosystem providers that are doing AI-powered test fits. Well, what those are doing is speeding up and automating the work of saying, this is the type of floor I need, give me a test fit. What we're essentially partnering with them to say is that floor type that you need, well, that's also coming out of the model now. Here's actually what this, given it's an employee pool of engineering and finance style workers in London, here's what we expect the space distribution and the usage patterns to be like. Put that as an input into the test fit process so that that process isn't 15 test fit iterations. Um, so kind of two really important use cases. Others we're starting to hear about, and again, if you're building this tool or you're working as a customer of these tools, these are other ideas for how the large spatial model will start to kind of show up in the ecosystem. Real-time availability and employee experience. How can prediction help us give that insight into the end employees as well, right? Think the Google, if you go to Google and you understand, I want to go to this restaurant, you start to see that like busyness factor of how, if you really want to go in, you probably want to go in the next hour, and how does it compare to how busy it actually is right now? That view into forward looking instead of not needing sensors to give an employee access to, hey, you won't have no conference rooms available right now, but instead saying, hey, the fifth floor probably has conference rooms available, but the fourth floor probably doesn't right now. That's the type of kind of insight the predictive large spatial model can enable. And then predictive building controls is really, really powerful, something we're starting to have a ton of awesome conversations around. The main idea is, and we've done this with where sensor data exists, customers have started to link those systems together to say, hey, I have occupancy data. How do I change up my controls on a dynamic basis, or at least at some even slow cadence basis to account for occupancy in how we expend our building management systems? The main the main idea that exists now is what if the spectrum you existed was you don't need sensors to do that, right? Today you have some schedule. If you have sensor data, it's going to live drive it and continuously optimize it. The predictive model can actually give you a significantly intelligent system by which to train and update your schedules. And majority of the savings are probably in that actual space. So, here's kind of some examples of other, use cases as well. We've talked a lot about, there's Wi-Fi data that exists out there. VergeSense is kind of another solution that can pull in that Wi-Fi data and give you estimation of people in the office. Well, here's an interesting kind of combo that says Wi-Fi data really gives you that demand line. It tells you how many people are in the office. It can't tell you how many people are in every conference room or every desk. But powering that with a large spatial model, you get a full picture, right? You get a full picture of seven, we know 85 people are on this floor based on the Wi-Fi systems. VergeSense integrates with them or even some of these other solutions that do. If a large spatial model exists, we can tell you how those 70 people distribute amongst the spaces that you have. We already talked a bit about how IWMIS platforms can provide scenario modeling, right sizing capabilities, that what if capability, design and test fit tools. I touched exactly on that. And then, we're talking to a lot of our customers, and we're going to be announcing something pretty soon in the next month related to this. But other system data exists already. Customers have either third-party sensors that aren't VergeSense sensors or measurements tools like video conferencing systems that have person count coming out of them. Well, that's a perfect, powerful measurement source. Back to what Kelby said, any amount of information is intelligent information to increase the precision of the prediction, and that can easily be pulled into the large spatial model as well. Um, Given time, this is, I want to take a couple of questions. Kelby, I don't know if you've answered a few of these, but
I answered one, yeah.
yeah, okay. So something for folks to think about, right, is other than the things we're talking about, other things that we're actually actively delivering, what other use cases of prediction exist? Because now we have an engine of capability that wasn't available before, and we're very excited to kind of work with the ecosystem players as well as customers on, what else can it do outside of these very powerful things that we're going all in on. Is there a question maybe for another one more minute for questions?
The one I think is unanswered, I think is Troy's question
Yeah.
is
Is
like,
there a reflective feedback loop? It's a good question.
yeah, one thing I could start with saying is like, yes, long story short is every time extra context is added, it updates obviously the predictions that are being made. It's sort of an interesting engineering detail. We've gone back and forth a lot of like, should it happen automatically? If you have scenarios already figured out, should those be locked in and you have to confirm that new context is added so it doesn't, unexpectedly change things. That's sort of an engineering detail that you have control over in our actual system. But long story short, yes, if you add new context, it does improve and change the output of the model. And interestingly enough, I actually think there's a lot of cool, interesting information encoded in your extra context moved it by this much. That's sort of a expression of how different your workforce or specific scenario is from like the default benchmark case. And that tells you a lot about your culture or your team or your company, et cetera. So um, exposing what that delta is important and tells you a lot about some of the characteristics of your actual usage.
Yeah. Really good answer there. If we have a couple minutes, please do ask additional questions. I'm going to kind of poll people on two things. One, see a poll coming up. Basically, if you'd like to get more information, either on how do you get started with the large spatial model API, or how do we work together on a more fine-tuned version of the model. That's something we didn't directly talk about today, but again, the capability of this model is as additional data comes in, a prediction kind of domain and precision increases. Let us know, and we'd love to kind of follow up with you on that. The other thing we would say is please do reach out to us if you have interest in the actual predictive planning product that we built around the large spatial model. Again, that's more for that scenario planning and what if scenario exploration that exists within it. Have to build something around the API. If you're interested in that capability, we have a product that is essentially very user friendly. You saw some screenshots of it, like the really cool workplace factors visualization. That's an example of our build on top of the large spatial model API. Um, and then the last, little thing we want to kind of plug quickly is we have a pretty awesome cadence of these conversations in which we talk about new impressive capabilities across our products. Office Hours goes really deep into it with an intimate group. The other is really around hearing from our customers, right? So we have a lot of our customers, key workplace leaders, come in and talk a bit about how they're making decisions, how they're actually using prediction, how they're using these products to make active decisions within their workplace. and their live environments. And it's a really powerful story. We're honestly honored that these customers do choose to come in and share their stories. It's in kind of the best possible form of advocation, and I think it's one of the most powerful things that we do across our fleet of content. Well, that's brings us to 1 minute. I'm going to stick around for a minute. Thank you so much for joining. If other questions come up, again, you know how to reach us. We'll be here, Kelby and I, for a couple more minutes to answer any questions in the chat. But thank you for listening to us. We're passionate about this. That's why we can go on for probably another hour if we needed to.
I also want to just say you sort of said it, Kanav. Anyone, we obviously sell a product. We have, a thing that we're a company that sells a product, but we love to talk about this stuff. If you have ideas or just thoughts on this and just want to talk about use cases you have or things you're doing or you're in the industry or doing something similar, we love to talk, even if it's not in the context of necessarily sales. So reach out either way if you're interested, and we love to chat about this stuff.
Awesome.
Cool.
Thank you so much, everyone.
Yeah. Bye, guys.